We'll discuss about LAQ1, efficiency of Carnot's engine. Carnot's engine is a reversible heat engine. And it works between two temperatures, T1 and T2. So T1 is the temperature of the hot source and T2 is the temperature of sink. It also contains working substance. That working substance undergoes four processes. The four processes are: first one, isothermal expansion. So we are heating the gas at constant temperature so that volume of the gas increases from V1 to V2. Next one, adiabatic expansion. So in adiabatic process, we are not heating anything here, but pressure, volume and temperature all will change. Next, the third process is isothermal compression. So in this process, we are removing heat from the source. Heat is taken from the source. And the last one, isothermal compression. And the last process is adiabatic compression. So these are the four processes, four stages, and it is a cyclic process. So wherever the gas starts the state, whatever the pressure, volume and temperature, at the same state the gas ends. So if you draw a graph between pressure and volume, pressure on y-axis and volume on x-axis, pressure on y-axis and volume on x-axis. So let me take capital A as the initial state. At this state A, P1 is the pressure, V1 is the volume, T1 is the temperature. So first of all, it is undergoing isothermal expansion. So in this process, the pressure decreases, volume increases, but temperature remains constant. In this process, the gas absorbs an amount of heat Q1. So pressure becomes P2, volume becomes V2, temperature is same T1, and reaches stage B over here, stage B. So next, it is undergoing adiabatic expansion. So in this process, temperature changes, volume changes, and pressure also changes. Pressure becomes P3, volume becomes V3, temperature becomes T2. But here no heat is supplied. So here heat is equal to 0 here. Okay, next one, and reaches its stage C. Next one, we are undergoing isothermal compression. So where the volume decreases but pressure increases but temperature remains constant. In this process, we are removing an amount of heat Q2 from the source, Q2 from the working substance, and the pressure becomes P4, volume becomes V4, temperature becomes T2 only, because temperature will not change. Next one, and it reaches stage D here. Next one, we are undergoing adiabatic compression. So where pressure decreases becomes P1, volume decreases become V1, and temperature increases become T1. Clear? And it reaches the final stage P1, V1, T1. So we are going to find out the efficiency of the engine, which is given by efficiency eta is equal to work done by heat absorbed, W by Q1. So in every stage we have to find the work done. And we have to find the efficiency formula here. So now one by one now. First of all, A to B. So one by one, A to B. So from A to B, the gas undergoes isothermal expansion. So in this process, work done is given by W is equal to W1 is equal to, or which is equal to Q1 is equal to, in the isothermal process, work done is given by nRT log to the base 10, log to the base E, log base E, V2 by V1, nRT. The temperature is T1 here, nRT1 log base E, V2 by V1. Okay, first equation. So next from B to C. So in the process B to C, work done is given by, this is adiabatic process, adiabatic expansion. So in this process, work done is given by W2 is equal to nR by gamma minus 1 into temperature T1 minus temperature T2, initial temperature minus final temperature. Okay, equation number 2. Next, C to B, work done is given by W3, which is equal to heat rejected Q2 is equal to nR, temperature is T2, log to the base E. The volume is changing from V3 to V4. So C to D here, C to D. Volume is changing from V3 to V4. Therefore, final volume is V4, initial volume is V3. This also can be written as W3 is equal to minus nRT2. We are reversing that log value here. We will be getting log V3 by V4. Equation number 3. And next one is last one. D to A. D to A is adiabatic compression. Given by W4 is equal to NR by gamma minus 1 into initial temperature is T2, final temperature is T1. We can reverse this, we will be getting W4 is equal to NR by gamma minus 1 into minus NR by gamma minus 1 into reversing T1 minus T2. So we got the 4 work done here. Now total work is given by adding all the work here. W is equal to W1 plus W2 plus W3 plus W4. So adding all the work you will be getting. W is equal to W1 is nRT1 log to the base E V2 by V1 plus W2 is NR by gamma minus 1 into T1 minus T2 plus W3 is minus, so minus not required here, W3 is given by NR temperature is T2 log to the base E V3 by V4, so minus will come here, minus NR by gamma minus 1 into T1 minus T2. So here these two terms will be cancelled and W is given by NR. I can take NR common. I will be getting T1 into log base E V2 by V1 minus T2 into log base E V3 by V4. So this can be taken as some equation number 5. So we got the work done here, work done. And heat absorbed is given by Q1. Heat absorbed Q1 is equal to nRT1 into log to the base E V2 by V1. So now we want the formula for efficiency, which is given by eta. Eta is equal to work done by heat absorbed. So what done formula? Just now we got that NR into T1 into log base E V2 by V1 minus T2 into log base E V3 by V4 whole divided by Q1 value NR T1 into log base E V2 by V1. So here NR is cancelled. So this can be taken as some equation number 6. So now we need to know the relation between V2 V1 and V3 V4. So we can see that B to C is adiabatic process and D to A is also adiabatic process. So we know that in adiabatic process, temperature T into V power gamma minus 1 is equal to constant. So this also we must remember for this formula here. Okay, now we shall take from B to C here, from B to C. So we will take from B to C now. From B to C. So from B to C. So at B temperature is T1, volume is V2. At C temperature is T2, volume is V3. I'll get now T1 into V2 power gamma minus 1 is equal to T2 into V3 power gamma minus 1. Some equation number 7. Okay, next from D to A. D to A. At D temperature is T2, volume is V4. At A temperature is T1, volume is V1. Applying the formula I will be getting T2 into V4 power gamma minus 1 is equal to T1 into V1 power gamma minus 1. Rearranging I will be getting T1 into V1 power gamma minus 1 is equal to T2 into V4 power gamma minus 1. Equation number 8. So now dividing equation 7 by equation 8 I will be getting. So we shall do it directly here. So T1 will be cancelled, T2 will be cancelled. I will be getting V2 by V1 whole power gamma minus 1 is equal to V3 by V4 whole power gamma minus 1. So from this I can write V2 by V1 is equal to V3 by V4, or V3 by V4 is equal to V2 by V1. Equation number 9. Substituting this equation number 9 in the place of V2 by V4 as V2 by V1 in this equation number 6. I'll get now efficiency eta is equal to T1 into log base 10 log base V2 by V1 minus T2 log base C. In the place of V3 by V4 I can write V2 by V1 by T1 into log to the base C V2 by V1. Okay, now efficiency eta is equal to, I can take log base C V2 by V1 as common. I'll get T1 minus T2 by log V2 by V1 base C T1. So this log term will be cancelled. So at last I got the equation as eta is equal to T1 minus T2 by T1. So this is the formula for the efficiency of Carnot's engine. Very simple and also very important.